In this video, we introduce the industrial network example project, and demonstrate the load flow calculation. This low-voltage network contains a number of loads, and DC and asynchronous motors, supplied by 2 generators and a connection to an external grid. Load flow studies are carried out to determine the steady state, active and reactive power flows and voltages in a network. Let us run the load flow calculation. The results can be seen on the single-line diagram, which has been colored to indicate low and high voltage and loading. Let us look in a network model manager. Looking at the lines, and sorting by loading, we can see that none of the lines is overloaded. Similarly, all the transformers are within their loading limits. If we look at the bus bars, we can filter to show those where the calculated voltage is more than 5% away from nominal. On one bus bar, the voltage is a little high. We can mark this in the graphic. As the LV network contains 2 generators, it would be interesting to see whether the load in the network can be supported if the external grid is not available. In this operation scenario, T1 and T2 off, these 2 transformers are switched off at the LV side, so that there will be no supply from the external grid. We will activate this scenario and run the load flow calculation again. The load flow converges, but we can see that generator 2 is overloaded. If the load flow is run again, with active and reactive power limits considered, we find that in this case, the load flow will not converge. To help understand how the loads in the network are supplied, let us look at the 2 feeder objects that have been created, one at each generator connection. The feeder definition algorithm determines which parts of the network are fed by which generator. Let us color the network according to these 2 feeders. The red part of the network is fed from generator 1, and the blue part from generator 2. In order to reduce the load on generator 2, we can reconfigure the network by closing this switch here at busbar 10, and opening this switch at busbar 7. This configuration has been set up in this scenario. We run the load flow again. The load flow now converges, and no lines, or transformers, are overloaded. The 2 generators are able to support the loads in the network, as long as it is appropriately configured. Another scenario of interest is whether the network can be fully supported by the external grid, if the 2 generators are not available. Let us activate another operation scenario to demonstrate this situation. The load flow is executed, and immediately we can see from the coloring of the network that the voltages are generally low. This can be seen in more detail in a network model manager. Such a scenario may not be acceptable. Solutions such as reactive power compensation might have to be considered.